Okay, sure. Let's move on to the second part of this chapter. So, the segments of the AD and BE are the median of the triangle ABC with the AB as the hypotenuse. So let's draw a picture first. Okay. So we have the with the AB as the hypotenuse is the ABC, and this is the 90 degree, right? If a right angle is constructed with the leg of the uh, AD and BE, okay, so AD and BE are the median, right? So AD and BE is the center, right? Is the midpoint. So AD and AD and BE the medians. So what is the hypotenuse? Okay, if we use the AD as the length, right? And if we use the BE as a length, okay, to construct the new one. So this one will be length as BE, okay? This length is BE. So what is the hypotenuse of this triangle, okay? So now let's see. Let's parameterize it, okay? So we have the C, we have this is the A over 2 and A over 2, right? This is the midpoint. So this is the B over 2 and the B over 2. Let's solve the AD, okay? So the AD square in the triangle of the ACD, right, is equal to the AC square plus CD square, right? Is equal to the B square plus the A square over 4. Similarly, we can solve the BE square is equal to the CE square plus the BC square is equal to the B square over 4 plus A square, right? So for the new hypotenuse will be the x. So x squared is equal to the AD square plus the BE square is equal to the 5 over 4 of the A square plus the B square. So now we can solve the x, right? It's 2 root 5 and root of the A square plus the B square. Okay, so question 184 is a very important questions. I want to give you a very general case of the what's the ratio with respect of the sine of its band angle. Okay, so in general case, let's see this. Okay, so let's say we have alpha and we have a beta. Okay, the ABC and this cutting is D. So we have this side is C, this side is B. Okay, so we want to find the BD over CD. Okay, in terms of the function of the B and C and the sine of the span and the splitting angle, okay, of alpha and the sine of the beta. Okay, so the first you can see the triangle ABD and the triangle ADC is equal to BD over CD, right? Because you share the same height, right? It's a different base, so that's why the ratio of the base is the ratio of the area, okay? And we can also use the law of sine to calculate the area, right? So this one is ABD is half of the C times the AD times the sine of the alpha. This one is half of the C times the B times the AD times sine of the beta. Then we can cancel and we can see it's C times the sine alpha over the B times sine beta. Okay, so this is a very important conclusions. Okay, it's very, very useful when you try to solve a lot of the like AMI, the USAMO questions. Okay, now let's see. So and the other one, and its complementary result is also very important. Okay, so from here you can also see the b c the c over b is the bd times the sine beta over the cd times the sine alpha. Okay, so you can see the c over b is cd C over B, right? Yeah, C over B is the BD times the sine of this angle and the CD times sine of this angle. Okay, these are complementary results, also very important. So now let's see how we can do it for this problem. Okay, so angle B is trisected by BD and BE, right? Is AC at D and E. Okay, let's draw it. Okay, angle B, so this is the ABC, is BD and BE. BD and BE. So this is the beta, beta, beta. Trisector, right? So now we can do it in an easy way. We can see we are going to solve the AD over EC, right? So AD over EC, they are separate, right? But we can do AD over DE times DE over CE, right? Okay, so the AD over DE, right, is equal to the AB times the sine beta over the BE times the sine beta, right? AB times this angle, BE times this angle, the common side, the area, right? Times the DE over CE, right? DE is BD times sine beta over the BC times sine beta, right? You can see all the angles are the same. So you can get it is AB times BD over BE times BC. Okay, AB times BD, BE times BC. Okay, next. So it's problem 189. The two altitude of scaling angles, what the scaling angle means A greater than B greater than C, no sides are equal, right? Then based on the area, right? You know the 2S equal to AHA is equal to BHB is equal to CHC. So we know the larger the side is, the shorter the altitude is, right? The height is. So the third altitude is also integer. So we know, okay, we know when altitude is 4, when altitude is 12, right? So we know 1 of 4 and the other 1 over 12. Remember, we have the 1 over HA should be less than 1 over HB plus the 1 over HC. So the two largest, the inverse of the two largest altitude together is greater than the inverse of the shortest, right? So we want the HA as big as possible, right? So that means we want to the HA as HA 1 over HA as small as possible, right? So now we can see if we have this 1 over HA, right? Now let's see, this is the first case. So now we need the 1 over 4 should be less than 1 over 12 plus the 1 over HA, right? So the 1 over HA, it should be less than 1 over 12 plus the 1 over 12. So this is no way, right? So 1 over HA cannot be the smallest one. So now let's make a HA a little bit less. So 1 over 4 1 over HA less than 1 over 12. Okay, now we have the 1 over, so 1 over 4 should be less than the 1 over 12 plus the 1 over HA. So now we should have it the 1 over HA should be greater than the 1 over 4 minus 1 over 12 is 1 over 6, right? So now we know HA, right? We read HA because it's integer. So HA should be the less than 6, right? HA should be less than 6, and also HA should be greater than 4, right? So the HA should equal to 5. That's the largest it can be. Problem 190. So the median of the of a triangle which are drawn from vertices of an acute angle 5 and okay, so we have a right triangle. Okay, then we have the median. We have the ABC, and we have the D and E. Acute angle of 5 and so we have this one as a 5 and this one as a root 40, right? AD, BE are median. Okay, this one AD is 5 equals root 40, and we have this one is 90 degrees. So we solved this problem before. We want to solve AB. So not C is the A over 2, A over 2, B over 2, B over 2, right? We want to apply the Pythagorean on the triangle ACD. ACD, yes. So now we know the b squared plus the a squared over 4 is equal to 25. Pythagorean triangle BCE. We know the a squared plus the b squared over 4 is equal to 40. Now we have the 5 over 4 of the a squared plus the b squared is equal to the 65. Right, so this is 1, 15, 13. So a squared plus b squared is equal to 52. Now we can solve the AB, right? So the AB is the root of the a squared plus b squared is equal to the 2 root 13. Angled triangle ABC. Then F is the midpoint of hypotenuse and BC is 3 times of the AC. So we have a right triangle ABC, BAC, and BC is 3 times of AC, so it's M and 3M, and F is the midpoint here, so we know the CF equal to BF equal to the AF. Then here is the D and E divided into this is into 3 equal parts. So we have the M and the M and the M. So now we can parameterize the BF and AF is equal to, this is the root 10, right? So it's 10 over 2, root 10 over 2M of 3. So now we want to prove that DEF, we want to prove that the DEF is right isosceles. Okay, so we want to prove the right isosceles, right? So to see this one, right? I mean, we have the midpoint here, so we are very strong hint is we to try to make the midpoint here, right? So if we have the midpoint on the AB and we have the midpoint on the BC, then we know the FM parallel to AC, right? and also FM is perpendicular to BC, right? So if they are parallel, we know this is 90 degrees. Okay, now let's see. I mean, the strong hint is if we can prove, right, to prove a triangle is a isosceles triangle. So if we can prove this is the median of to the base is also perpendicular to the base, right? Then we can do it. So now we can guess is the FM already perpendicular to the base, right? Now let's prove the FM is also the median to the base. So we have the BC is equal to the 3M, right? And M is the midpoint. Midpoint, right? This tells us the BM equals the CM equals 3M over 2, right? So now it's this one is M over 2, this one over M2. So now we prove that the FM perpendicular to BC and the FM is median of DE, right? So now you can see the triangle DFE is isosceles triangle. Okay, with DF equals to the EF. Okay, now we are missing the right angle, right? Okay, so if we are missing the right angle, the goal is to prove the angle DFE is 90 degrees, right? Okay, so now let's starting from the side. Okay, so we know the BF, we know the triangle BFM, right? You know the BF is equal to the root 10 over 2 of the M. Now you know the BM equal to 3 over 2 of the M. By Pythagorean, you know the FM equal to the root of the 10 over 4 minus what? 9 over 4 of the M is equal to M over 2. So this is M over 2, right? So M over 2, this is the 90 degrees. So you know this one is 45 degrees. You know this one is 45 degrees, right? Now finally you can know. Let me use another color, okay? Yeah, this is M over 2, right? So 45, you know this one is 90 degrees. Okay, I left all the work how to write it to you. Question 193. Okay, so the median to a 10 centimeter side of the triangle has a length of 9. Okay, so the median, for example, this side is 10 centimeters, and this one has a length of 9. Maybe say ABC, AD is equal to 9, right? And it's perpendicular to a second median. So a second median is here. So it's perpendicular to a second median, right? So this is the centroid point G. So because AD equals to 9, the first thing we need to know is the centroid. So it's 6 and 3. And once we know the 6 and the 3, we have a right triangle DGC, right? Okay, if you see the DGC is a right triangle, right? So now you know it's 3 and 5 and 4, right? Once you figure out this 4, right? The CG over CF is 2 over 1, right? So now you know this is 2, right? Okay. So once you know this is the 2, now let's see how we can calculate it. Okay. So in this case, we can calculate the triangle, the CDG is equal to half of the 3 times 4 is 6, right? We know the CDG, right? Now we know the triangle, the BCG is 2 times of the triangle CDG, right? Is 12. Okay, so we're expanding from this triangle to this triangle, right? And also we also need to know, we also know the ABC over triangle BCG is equal to 3, 2, 1, right? So this is 2, so this is the total is 3, this is the one piece, right? That's common base, height is 3 to 1. Now we know the triangle ABC is 3 times 12 is 36, okay? So you don't need to extrapolate this information, right? But this is the free to know. Just yeah. So that's it for the all the selected problems for this chapter of the chapter 11. Thank you. Bye bye.